The Earth's atmosphere is the bane of astronomers, preventing from the exploration of deep space. Imagine looking up at the sun from the bottom of a swimming pool. The sun would be blurry and out of focus, right? This same concept applies to stars in outer space that we look at through the atmosphere. The blockage of light is what makes stars twinkle, and it distorts the image.
The idea of sending a telescope into space was first proposed long before the first satellites were launched. Long before anyone even dreamt of sending astronauts to space, German rocket scientist Hermann Oberth was a pioneering thinker of his time and suggested a space-bound telescope as early as 1923 in his book about a space telescope avoiding frustrating problems such as cloudy and misty observing nights, the twinkling stars even on clear nights, and the absorption of the ultraviolet and infrared parts of the spectrum.
It took many years before technology caught up with Oberth's idea. The American Lyman Spitzer proposed a more realistic plan for a space telescope in 1946 and lobbied for his idea for almost 30 years. In the 1970s, NASA and the European Space Agency took up the idea and proposed a 3-meter space telescope. Funding began to flow in 1977, and it was decided to name the telescope after Edwin Powell Hubble, who had discovered the expansion of the universe in the 1920s. Although the Hubble Space Telescope was downsized to 2.4 meters, the project started to attract significant attention from astronomers.
The precision ground mirror was finished in 1981, and the assembly of the entire spacecraft was completed in 1985. The plan called for a launch of NASA's space shuttle in 1986, but just months before the scheduled launch of the Challenger disaster caused a year-long delay of the entire shuttle program. Hubble was finally finished in 1990, and the tension built up as astronomers examined the first images through Hubble's eyes.
As in all good adventures, success does not come easily. It did not take long to realize that Hubble's mirror had a serious flaw. A focusing defect prevented Hubble from taking sharp images. The mirror edge was too flat by a mere 50th of the width of a human hair. Over the next months, scientists and engineers from NASA and ESA worked together and came up with a superb corrective optics package that would restore Hubble's eyesight completely.
A crew of astronauts carried out repairs necessary to restore the telescope and its intended level of performance during the first Hubble servicing mission in December 1993. As the first series of planned events of orbiting the Hubble Space Telescope, the first servicing mission, STS-61, in December 1993, had a lot to prove and a lot to do. The mission's most important objective was to install 2 devices to fix Hubble's vision problem. Because if Hubble's primary mirror was incorrectly shaped, the telescope could not focus on the light of an object to a single sharp point. Instead, it saw a fuzzy halo around the objects it observed.
Once astronauts from the Space Shuttle Endeavour caught up with the orbiting telescope, they hauled it into the shuttle's cargo bay and spent 5 days tuning it up. They installed 2 new devices, the Wide Field and Planetary Camera 2, WFPC-2, and the Corrective Optics Space Telescope Axial Replacement, or COSTAR. Both WFPC-2 and the COSTAR apparatus were designed to compensate for the primary mirror's incorrect shape. Once Hubble received its eyeglasses,
although the 4 subsequent servicing missions were at least as demanding in terms of complexity and workload, SM-1 captured the attention of both astronomers and the public at a large degree that no other shuttle mission since has achieved. Meticulously planned and brilliantly executed, the mission succeeded on all accounts. It will go down in history as one of the highlights of human spaceflight. Hubble was back in business.
Since Servicing Mission 1, 4 other servicing missions have been carried out. There is no question that Hubble's first-generation cameras gave us remarkable views of very distant galaxies. However, the light from the most distant galaxies is shifted to infrared wavelengths by the expanding universe. To see these galaxies, Hubble needed to be fitted with an instrument that could observe infrared light.
During the 10-day second servicing mission, STS-82, in February 1997, 7 astronauts above the Space Shuttle Discovery installed 2 advanced instruments. The near-infrared camera and multi-object spectrometer, or NICMOS, would be able to observe the universe in infrared wavelengths. The second instrument, the Versatile Space Telescope Imaging Stereograph, STIS,
Both instruments had optics that corrected for the flawed primary mirror. In addition, they featured technology that wasn't available when scientists designed and built the original Hubble instruments in the late 1970s, and opened up a broader viewing window for Hubble.
Servicing Mission 3 was split in two servicing missions, 3A and 3B. NASA decided to split the third servicing mission, SM-3, into two parts, SM-3A and SM-3B. After the third Hubble's 6 gyroscopes failed, the second part of the mission, SM-3B, took place March 12, 2002.
On November 13, 1999, the Hubble Space Telescope was placed into safe mode after the failure of a fourth gyroscope. In safe mode, Hubble could not observe targets, but its safety was preserved. This protective mode allows ground control of the telescope, but with only 2 gyroscopes working, Hubble cannot be aimed with the precision necessary for scientific observations in the sky. Controllers closed the aperture door to protect the optics and aligned the spacecraft to ensure that Hubble's solar panels would receive adequate power from the sun.
On December 19, 1999, 7 astronauts boarded the Space Shuttle Discovery to pay the Hubble Space Telescope a special holiday visit. After a successful launch and several trips around the Earth, the crew caught up with the Hubble and hauled it to the shuttle's cargo bay. 6 days and 3 6-hour spacewalks later, the crew had successfully completed Part A of the 2-part third servicing mission, which had them replacing worn or outdated equipment and performing several critical maintenance upgrades.
Servicing Mission 3A, STS-103, was a busy one. The most pressing task was the replacement of gyroscopes, which accurately point the telescope at celestial targets. The crew, 2 of whom were Hubble repair veterans, replaced all 6 gyroscopes, as well as one of Hubble's 3 fine guidance sensors and a transmitter.
The astronauts also installed an advanced central computer, a digital data recorder, and electronics enhancement kits, battery improvement kits, and the new outer layer of thermal protection. Hubble was good as new.
The Discovery crew deployed Hubble back into orbit on Christmas Day and returned to Earth, landing safely on December 27th. Once the mission ended, scientists turned on the telescope science instruments, which were taken offline during the service mission, and took test pictures to make sure the instruments were functioning properly.
On March 1, 2002, NASA launched the Space Shuttle Columbia into orbit 360 miles above Earth, where its 7-member crew met with the Hubble telescope to perform a series of upgrades. Servicing Mission 3B, also known as STS-109, was the 4th visit to Hubble. NASA split the original Servicing Mission 3 into 2 parts and conducted the first part, Servicing Mission 3A, in December 1999.
The highly trained astronauts performed 5 spacewalks. Their principal task was to install a new science instrument called the ACS. The first new instrument to be installed at Hubble since 1997, ACS brought the nearly 12-year-old telescope into the 21st century. With its wide field of view, sharp image quality, and enhanced sensitivity, ACS doubled Hubble's field of view and collects data 10 times faster than the Wide Field and Planetary Camera 2, the telescope's earlier surveying instrument.
The Hubble gets its power from 4 large flexible solar array panels. The 8-year-old panels were replaced with smaller rigid ones that produce 30% more power. Astronauts also replaced the outdated power control unit, which distributes electricity from the solar arrays and batteries to other parts of the telescope. Replacing the original unit, which has been on the job for nearly 12 years, required the telescope to be completely powered down for the first time since its launch in 1990.
Servicing Mission 4 was the hardest and most intense servicing mission. It installed many new versions of the old devices, such as cameras and optic corrections, so that the Hubble could continue its work. In addition to these things, it provided a new core operating and memory system, which replaced the old after it began to break down.
Since SM-4 is expected to be the last astronaut mission to Hubble, one of the goals was to reinforce and reinvigorate the telescope's basic flight systems. Astronauts replaced all of Hubble's batteries, which were 18 years old, with new improved ones. Astronauts installed 6 new gyroscopes, which are used to point the telescope, and a fine guidance sensor, which locks onto stars as part of a pointing system.
Because of the retirement of the last space shuttle, the 4th servicing mission is the last. It came with a package to help Hubble back to Earth and gave it the technology to end up its days in a frenzy of scientific discoveries. The Hubble telescope is projected to last until 2020 and will have served humanity for 30 years since launch. It has discovered many things in its lifetime, and it will live on in history.